Good morning, everybody. It's great to be here. I'm thrilled to be able to come and talk to you a bit today about seizing the AI advantage, because it's a topic I spend quite a lot of time thinking about. So in the next few minutes, I want to really spend some time encouraging all of us in the pursuit of advantage, and also share a few thoughts on where the next wave of AI will take us, and therefore where there is advantage to be gained. But in the first instance, I just want to pause for a minute on this word advantage, because we all have this sense of innovation spreading and of society progressing. And so in many ways, we all advance together. But I want to suggest that the reward for this advancement doesn't always get spread equally, and that fundamentally the reward for advancement tends to fall to those organizations and those countries who do things differently, who do things better. And so for the next few minutes, I'm going to go with this definition, which fundamentally is trying to encourage us all to identify what is the thing that we are going to be able to do which is better than everybody else. Now, this is Cambridge and Cambridge Tech Week, and Cambridge has an amazing track record for delivering advantage through deep tech. And like many of the tech clusters around the world, Cambridge is really gifted and blessed with a number of deep thinkers. And deep thinking is incredible. It can really allow us to see the world in new ways, from understanding how gravity works to training AI to be able to predict the function of proteins that we've not discovered yet. Now, I'd say not all deep thinking leads to advantage, but if deep thinking is about science and technology, and it's applied to meeting needs in a new and better way, critically usually with some solid engineering behind it, then this can lead to some sustained and significant advantage. And this is what we call the deep tech approach, or a deep tech strategy. Now, the most incredible thing about this is that it really is open for everybody. And this is a strongly held belief at Cambridge Consultants. There are many technology startup companies, certainly in the tech cluster in Cambridge, but also globally, who are really deploying this approach to build their businesses. And locally, organizations like Pragmatic Semiconductor or New Quantum are well-known examples. But looking further beyond this, there are many sectors who are using this approach. In the pharmaceutical sector, to discover and develop new proteins and new drugs requires an amazing amount of technology. In the telecoms industry, which Tim's mentioned already, to transition to satellite phones and get those services working is remarkable. But I'd also say there are other areas which you might be surprised to know also apply this kind of approach. So to make the perfect cup of coffee every single time is an amazing feat of science. Likewise, being able to deliver the most amazing guest experience at theme parks or other venues. These are just a few examples of where organizations across any market apply this deep tech approach to give them advantage. It gives you new ways to win. Okay, so what about AI? Now, AI, as we've already touched on, is a very big field. And in the interest of looking for advantage, I'm going to try and look ahead to where AI is going next. Over the past 10 years, we've gone through several phases of AI. It started with what you might call the perception phase, where we were focused on using AI to identify objects in images and to recognize speech. We've then been all amazed by the incredible achievements of generative AI, creating incredible images of things that the AI imagines. And more recently, of course, using large language models to enter into conversation and create content and text for us. In the last 18 months or so, these large language models have been given agency by connecting them with tools and data and memory. And this is what we're calling agentic AI. But most excitingly for me is in the last 12 months or so, what's really risen to prominence is an area called physical AI. And this is something that I think is super exciting, and I think there's plenty of opportunity for many organizations to seize advantage. It will profoundly affect the way in which humans and AI interact with each other. Now, physical AI is at its heart about giving AI the capability to understand the real physical world, the kind of capabilities that we all develop when we're quite young children. So knowing that an object still exists even if you can't see it, or knowing that if you drop something, it will fall, or understanding that you can squash some things but not others, or if you lift a sack of potatoes, then its weight distribution changes as you lift it. All of these things really can be summed up by the idea of giving AI a kind of concept of common sense. Now, this is an incredible area of development, but because it's also happening in parallel with developments in hardware, so batteries and motors and sensors. Just this year, we've seen a remarkable progress in the capability of intelligent robots and humanoids in particular. At the beginning of the year, we saw 2 robot arms collaborating to do some very complex origami. That was in DeepMind's lab in London. In the Beijing half marathon, there were 21 humanoid robot entrants, 6 of whom finished the course. And then since then, we've seen robot boxing matches, we've seen humanoid robots doing cartwheels. And this is just a few examples which illustrate the real meteoric rise in capability we've seen in this area. Now, this is also backed up by analyst projections, where they believe that if you look just 10 years ahead, we may have a global population of humanoid robots of 13 million. So that's more than most European countries. And looking further ahead, the value of this market could be $5 trillion, which is twice the value of the world's top 20 car makers. So plenty of opportunity to be seized. But then the question is, how do you seize the advantage? How do you actually take advantage of this opportunity? So to start finding that out, my team started doing some deep thinking. And the first thing we did was try and break down the technology stack which sits behind a humanoid or intelligent robot into 3 work streams. And on the left here, you can see an example representation of the technology stack in an intelligent robot, from the hardware platform at the bottom layer through motion control and perception systems and cognition and right up to human interaction. And we took that apart and we really created 3 work streams to go and explore this question of what would it take to generate advantage in this space. And these were whole body dynamics. What does it take to get a humanoid to move fluidly and safely in the same spaces as humans are? Secondly, fine manipulation. For robots to be valuable, they've got to be able to interact with the world in the same way as humans do, from sorting parcels to stacking shelves to maybe even doing the cooking. And lastly, that topic of human-robot interaction. Humanoids, more so than any of the robots we've had today, will have to interact with other people in a much more natural way. They have to become part of the team. So, on the whole body dynamics topic, we, in common with much of our robot control work, rely heavily on simulation. It's faster, it's cheaper, it's safer than doing it for real. And here you can see a few examples of us training our models to follow a sequence. What we're doing here is using a combination of reinforcement and imitation learning to try and coordinate the 23 degrees of freedom these robots have to move all in unison. And all of their joints are being updated, the position updated 50 times a second. So to do this, we have to run thousands of simulations on the supercompute in our facilities. And we're getting some pretty good results in simulation, but the area which we're really exploring right now is how do you translate that simulation result into the physical robot? And that requires some quite significant software engineering and deep thinking, particularly to marry that performance from simulation into real world. On the fine manipulation topic, our team have been busy retraining, fine-tuning NVIDIA's GR00T foundation model. So new foundation models are being released now to really target this topic. And so what we were happy with is that we only took about 300 examples to retrain that model to work on our robot, which in the end turns out is a good thing. Because one of the things we've discovered is there's a real scarcity of training data in this area. Unlike large language models, which you can train on all of the corpus of the internet, the available data to train a robot to do this kind of task is not there. And so what we've had to do is install motion capture rigs and create teleoperation pipelines to be able to start collecting our own data to accelerate our work in this area. And then the last one is human-robot interaction. And what we're going to do is listen in here to a conversation between my colleague Ali and the robot. What you can see here is through the robot's eye view. So we have both a normal camera and also a depth-facing camera, a depth-sensing camera. And one thing which is slightly difficult to see is on the white table in the middle, there's a Cambridge Consultants mug. And Ali also has another one which is hidden from view that you can't see. Let's see.
Can you move the cup over there?
Let me take a look. Do you want me to move the one cup on the middle table to the rightmost table from my point of view?
No.
Ready for your command.
Can you move the cup over there?
Let me take a look. There are 2 cups, one on the white table and another on the blue table. Please point at the one you want me to move and repeat your command. Ready for your command.
Can you move this cup over there?
Take a look. Do you want me to move the cup from the rightmost table to the leftmost table from my point of view?
Yes, please.
Isn't that cool? So what you can see there is Ali and his team have created this framework to allow humans and robots to interact in a much more natural, team-like way. He can use a combination of verbal and non-verbal cues to give his instruction. So we brought together human speech, we brought together a combination of pose and gaze interpretation, object recognition, and spatial reasoning to create this framework. And the next thing, of course, for us to do is to bring these three work streams together. So stay tuned for next developments. And of course, we do this so that we can be well positioned to give our clients the advantage in these new emerging areas. So to wrap up, I truly believe that the next wave of AI is going to be physical, and we're right at the beginning of that. So what that means is that a number of the problems in this area haven't been solved yet, but they are being solved right now. And so that means the organizations who are engaging in this area will be the ones who seize the advantage. And over the next year or two, I anticipate seeing humanoid robots being deployed into real service. But what's particularly exciting about this is it requires an entire stack to be able to serve those robot services. We've got the foundational robotic capabilities, which I've touched on now, but we'll require abilities to teach robots just under simple human instruction how to do new tasks. And then, of course, we'll need an orchestration system to manage their to-do lists. And I generally believe that there are opportunities to seize advantage in this area through that whole stack. So what I want to leave you with is an encouragement to pursue this idea of advantage. You know, what is the topic which we all as individual organizations and countries can do which is better than everybody else? And I have a real excitement about the potential of physical AI. If any of you are working in this area, I'd love to chat, or indeed if you'd like to know more about what this could mean for you, please do get in touch. Thank you very much.
Thank you, Tim. Tim, can I ask you a quick question before you go? That was superb. Can we have another round of applause for Tim Ensor, please? I'm going to be applying for work experience in your team now.
You'd be very welcome.
So is there a type of conversation you'd love to have about this? Because in a sense, the world is your oyster. You could work with any sort of organisation in any industry. Is there a sort of particular field that you think, oh, I'd love to have more of an explore in this particular part of the world?
Yeah, no, it's really interesting. So a lot of the conversations we're having in this topic at the moment are in the logistics space.
Yep.
So, you know, thinking about the challenges that those organizations have in labor,
yes,
to be able to get enough people into the warehouses, into the sorting areas, to be able to actually do the work.
Yeah.
So they are definitely going to be advanced in this topic. Yeah. I think the area which are going to be interesting next is, okay, what are the other fields in manufacturing or in logistics or in kind of personal care which are going to come next? So those are the things we're exploring.
Fantastic. We're going to need a bigger palette. That's the
yes,
challenge for us. So logistics, my job is to get us from A to B. So for now, Tim Ensor, thank you very much.
Thank you, Ollie.